Problem 38 states, given the following insertions and deletions, select the correct red-black tree. So we have 5, 16, 12, 14, 13, 9, 6, 18, and 20. And we're going to delete 12, 9, and 6. So let's go through and work on this animation and see how it works. So we're going to initially insert 5, and 5 is going to become the root node, and it's going to be black. Then we're going to insert 16, and 16 is going to be the right child of 5. So now let's insert 12 and see what happens. Initially, 12 is going to become the right child of the left child of 16. And then what's going to happen is we have a case where we have a black uncle and a red parent, because the black uncle is null. And so what we're going to see is we're going to go from case 1 to case 2. We're going to move 12 up here, and 16 is going to move down and become the right child of 12. So now this takes us from case 1 to case 2. In case 2, we have a red rotated value with a grandchild, parent, and grandparent here, where the parent and child are red, and the node is black, which means we are going to rotate. And then the last step here is in this case 2, we recolor the parent and the grandparent. So 5 is going to become red and 12 is going to become black. Next, we're going to insert 14. And now we're going to have a scenario where 14 is the left child of 16, and it has a red uncle, 5, and a red parent. In this scenario, we will recolor the parent, the uncle, and the grandparent. And now we have the recoloring. And then the last case we had, which was case 0, is where we always recolor the root node. So 12 is now going to become black. So now that we've inserted 14, we are now going to insert 13. When we insert 13, what we're going to see here is now we have a black uncle here, and the parent is red, and the child is red, and so we have case 2. So now we are going to rotate right. 14 is going to become the root of the subtree, 16 will become its right child, and 14 and 16 will be recolored. So now we're going to insert 9. 9 is going to become the right child of 5, and nothing is going to happen. We leave it alone. Now 6 is going to become the left child of 9. In this scenario, what's going to happen is we have this rotation. We have the black uncle. So now we're going to move up 6 and move down 9, like so. And now we're in case 2. So now we're going to rotate. 6 will become the root of the subtree, and 6 and 5 will change color. So now here 6 is the root of the subtree. Now we recolor the original grandparent and parent. So 5 is going to become red, and 6 is going to become black. So now we insert 18. 18 is going to be a red child, which is going to be the right child of 16. So now we have the red uncle, red parent, black grandparent scenario. So now we are going to recolor 13, 16, and 14. And then we leave the tree alone because we have balance. The last thing we're going to do is we're going to insert 20. So now we're going to insert 20, and 20 is going to become the right child of 18. And so now we have this scenario where the uncle is black. So we're going to rotate left this time. 18 will become the root of the subtree. 16 will become 18's left child. And then we are going to change the color of 16 and 18. So now we've performed all the insertions. The first thing we're going to do now is we're going to perform the 3 deletions. We are going to first delete 12. When we delete 12, what's going to happen is we're going to go to the left-hand side, and we are going to get the largest value from the left subtree, which is 9, and then we're going to delete that node. So we do not encounter any other cases in the tree. So therefore, we leave the tree alone. Now we're going to delete 9. So 9 is the new root. So what we're going to see is that 6 is going to be moved up here. And then what's going to happen is that we're going to grab 6's child, and then 5 is going to become black. So we're still going to have a valid B tree, red-black tree. And then finally, we're going to delete 6. So here we go. 5 has been recolored. When we delete 6, it's going to grab the largest value from the left subtree, which is 5. So when we get here, now it's gone, and we've now encountered a scenario where we have violated our rule. So what we need to do here is we're going to have to rotate left. 14 is going to become the new root of the tree. 13 is going to become the right child of 5. And then 5 and 14's colors are going to change. We step forward. And then we're going to change 5 and 14. And then we leave the tree alone. So now we have 14, 5, 18, and then 13, 6, and 20 in that are red nodes. So let's evaluate what we came up with. And we see that we came up with the answer of C.